All right, so I thought I would give you guys some more examples on the composition of functions problems. Some of these are going to be similar to the assignment that I'm going to post with this. So if you need to reference this, go for it. So for this one, we have h of t equals t minus 5, and g of t equals negative 3t squared minus 5t. And we're trying to find h of g of y squared. So the y squared is what we are substituting in here, and because g is the next one, we're substituting y squared into g. So we have g of y squared. So we have negative 3 times y squared squared minus 5 times y squared. So we're going to simplify this. And the only thing to simplify is this y squared squared. So that means we multiply the exponents. So we have negative 3y to the fourth power minus 5y squared. And because they have different exponents, that's as far as we can go with that. So then the next part of this is h of g of the y squared, which means we're taking this answer and we're plugging it into t and h of t. So we have negative 3y to the fourth minus 5y squared minus 5. And there's nothing else to simplify there, so that's as far as it's going to go. And that's the final answer for this one. So then the next one, I have an extra example of, it's a little bit longer. So we have, if g of x equals x squared minus 1, find g of h plus 2. So this one, we're plugging the entire h plus 2 into x. So it becomes h plus 2 squared minus 1. And just as a refresher, when you square a set of parentheses, you don't square each individual thing. It's the set of parentheses times itself, and then we have to use FOIL or the distributive property twice. So we have h times h, which is h squared, h times 2, which is 2h, and then distribute this. So we have 2 times h, which is 2h, and then 2 times 2 is 4, and then we still have the minus 1 to bring down. And now we're just going to combine all of our like terms. So there aren't any more h squareds, so it stays h squared, and then we have 2h plus 2h, which is 4h, and then 4 and negative 1 is 3. So that simplifies to h squared plus 4h plus 3. All right, so our next one, I specifically picked one like this because of the weird fraction situation that's happening. So we have if f of x equals 1 over x and g of x equals x plus 1 over x, find f of g of x. So remember, if you have this open circle, you can rewrite it as f of g of x, so that you know the g goes into the f function. So if we do this, we have 1 over, and then all of this is going into this x spot. So we have x plus 1 over x. And this is not an acceptable way to write a fraction. We can't have a fraction within a fraction. So to get rid of that, we're going to do basically keep, change, flip. So you're keeping the denominator as 1. You're changing division to multiplication, and then you're flipping this over so that it's x over x plus 1. And then when you're doing that, you're essentially doing 1 over 1 times x over x plus 1, which when you do that, we're left with just x over x plus 1. So then f of g of x is just x over x plus 1. All right, and then the last extra example I have is a little bit longer and a little bit more complicated, because if we know f of x equals x squared plus 2x, then we're trying to find f of a plus h minus f of a. So we have two situations here. So we're plugging a plus h into x, and then we're also plugging a into x, and then we're subtracting those two things. So if we write that out, it looks like this. So we have a plus h squared plus 2 times a plus h minus, and I'm going to put all of this in brackets for now, a squared plus 2 times a. And we're going to just kind of ignore that half, this like right half for now, and just focus over here. So we have a plus h squared. So remember, we write them out again, and we do distributive property twice. So a times a is a squared. A times h is ah or ha. It doesn't really matter, the order right there. And then h times a, and then h times h is h squared. All right, and then now we're going to take this 2 and distribute it into this set of parentheses. So we have plus 2a plus 2h. All right, now, in between that, I'm going to put this in a different color here. We are going to simplify, let's use this blue. We're going to do this minus, and then a squared we're going to leave as a squared, and then this becomes 2a. And we're going to distribute this minus as a -1 into here. So we have minus a squared minus 2a. So now we have all of our parts distributed, and now we have one line where we can just combine like terms. Okay. So let's see, we'll go with yellow and just start writing out our combined terms. We have a squared and minus a squared. So those are actually going to go away. And then if you look over here, we have a minus 2a, and over here we have a plus 2a. So those are going to go away as well. And now look at your squared term. So the only squared term we have left is h squared. So let's put h squared first. And then we have ha plus ha, which becomes 2ha. And then the only thing we haven't done anything with is this plus 2h. So that is our final step right there. So our final answer is h squared plus 2ha plus 2h. If you have any more questions, just let me know.